Just to give some introductions, first of all, as Adam mentioned, I've been consulting for 15 years under various guises, lots of different clients, small clients, big clients. I'm one of the co-founders of the PyData London community that we have here. We started this 6 years ago with our first conference, and in our meetup series, the meetup has grown to, we're just shy of 10,000 members now, with 200 people coming to our monthly meetups. Free beer, free pizza, high quality data science talks, and then the pub afterwards. You're all very welcome, and I encourage you to come along. I'm also an author of High Performance Python with O'Reilly. That book is 5 years old now, and Python 2.7. Python 2.7 is about to be deprecated this year, so my co-author and I are working on the second edition. That'll be released next year. We do have copies of the current edition for signing tomorrow. It's perfectly correct, except for Python 2.7, so on your print statements you have to put round brackets. Otherwise, it's all correct. And there's obviously technology we've missed in the last 5 years, so it needs updating. But if you'd like to learn about high performance, which is not the subject of today's tutorial, please come and queue up for one of those, and there's a limited set that O'Reilly have kindly sent us. I'm also a Pluralsight author. I've got a one video course up there. Happy to talk about that if you're interested in Pluralsight. Here sponsoring this weekend. So I do a couple of things. I help companies like the ones you saw before build up their data science plans and execute on them. I've been doing this for 15 years. I've gone from developing IP to more frequently helping teams to develop their own IP now. And one of the ways that I deal with that is to train. I've got a couple of public courses. What we're going to cover here is not from a public course, but I really care about my training approach. So I'm a little bit nervous about giving a course that I haven't even finished yet. So I'm after your feedback after this one. I would very much like some feedback on how it's set up, what you learned from it, what problems you came in with, and whether this addressed some of your problems. Requirements for the day. It's a standard PyData environment. If you're using Anaconda, that's brilliant. You'll have it all already. We're using Pandas, Seaborn, and a Jupyter notebook. One notebook that you've already cloned from the GitHub link, and one data file, which is open data. And you can do a Conda install, Seaborn, Pandas, and Jupyter, I think, without commas. Someone tell me without commas. Yeah, I shouldn't type that in the slides. Conda install, anyway, those three, and you'll have the environment. But you should have that already if you've got an Anaconda environment. So I'm assuming that you know some Pandas already. You want to learn about time series, particularly some manipulation and visualization. Right. Let's get going. So, first of all, can you all see the notebook? Go full screen. Get rid of my header. So, is that big enough to see? And those lights are really bright. So if you want to, I'm very happy to answer questions. Wave at me, and brilliant, thank you very much. That's easier. All right, you can wave at me. You can shout out loud. I'm very happy to have discussions. I don't believe we're going to get to the end of this notebook, depending on how well we do with the few questions that arise during it. And I'm going to ask you questions, and I'd like your feedback on the things that you're seeing. It'll be much easier for you if you're rendering it locally, because then you can have a look at the graphs that we're drawing. They may not be super clear on the lower resolution up here. If it doesn't work on your machine, turn to your neighbor and share with their machine, and you'll see lots of pretty pictures. So who has done datetime manipulation in Pandas before? Okay, some of you have. How many of you use Pandas at least a couple of times a month? Okay, how many of you have not used Pandas in the last few months? Okay, only a couple of you. Good, right. I apologize, you may struggle a little bit because I'm not introducing Pandas here. The notebook runs completely as it is, and you'll pick up Pandas as we go through it, but I'm not introducing the basics of Pandas, just the basics of visualization and time series. But that suits almost all of you in the room, so that's brilliant. We're on the right page. So, I've imported Pandas as PD, the normal way to import Pandas. We can make datetime objects really easily inside Pandas because it has some good string processing routines to make data objects, and then we can do things with those data objects. Particularly, we can make some time series, so dates at a certain regular frequency, using some existing data. That's what we're going to use here, some German open data for utilities, solar and wind power and energy consumption, and then look at those over a number of years and look for patterns in that data set. But first of all, we need to make some date times and see how they work. So, super easy. We just do two date time, so pandas two date time, give it a string, years, months, days, maybe a time, and it creates an internal timestamp object. So we have a regular object, and then we can create lots of these and we can vary them. We can use deltas, so we can take two timestamps and take a difference, and we can do things with those differences. So we have a very standard and easy to use interface. Anyone who's done date time manipulation in regular Python with their date time objects knows that things are great until they become not great and they get weird. And when they become weird, they get really hard to debug. And as soon as you introduce time zones, things get even weirder. Has anyone had fun mixing time zones and non-time zone data before? And by fun, I mean put your hand up and groan. But yeah, okay. It's always a pain in the backside. So Pandas deals with a lot of this for us. So we can make date times just off of dates as well, and we can do just years and years and months and the like. We can add time zone information, and here I'm using a standard ISO 8601 date format. Date times are one of those annoying things in the world where everybody feels compelled to create their own new format for a thing, which looks a little bit like the other standards, but is a bit different again. So we have an n+1th standard going on. There's an ISO 8601 standard. Just use it. Your life will be so much easier if you use it. Please don't decide to be slightly American or slightly European or slightly something else or save a couple of bytes and make it a bit smaller or lose the minuses or the spaces or the colons just to save some characters in your logging. It's a really bad idea. It's just much easier to express things in ISO 8601. Every parser on the planet will understand it. There'll be no more confusion. And we're not constrained by space like we were 30 years ago. So just write out long-form dates. Your life will be so much easier. This data set doesn't use ISO 8601, but it parses okay anyway, because Pandas is pretty good at picking up different date times. So just a few more examples. We can create one off of a string and force UTC as a time zone, or any other time zone that we want in there, but UTC is a nice standard. We can pass in, that's month, day format, and we can flick that around with a day first flag. So depending on whether you're American or European, you put days and months before each other in different ways. Yep. Zoom in like that. All right, okay. We'll see how we go. Can you see it on your screen? Oh, okay, right. I'll see how we go with the graphs. They may not fit on the screen. I may have to zoom in and out, but that's fine. Just remind me and we can do that. We can make ranges as well. So there's a very convenient date range operator. Here I'm saying from 2018, January the 1st, I'd like 10 items at a frequency of days, single days. So I get 2018 0101 to 0110. So I get 10 days worth. And I can do this hourly. In fact, there are some rules down below. I can do daily, business daily, so it's a 5-day cycle, weekly, monthly, quarterly, hourly, by the minute, anything you want in between there for any length. So that's really powerful for coming up with a structured range. So if, for example, you've got a time series log of stuff, you've got a pile of numbers, but no date range associated with them, you can add that date range and then merge the data together. I don't know. Good question. But no, I don't know. Pandas is pretty good for all of its business rule handling. Because it was designed by Wes McKinney, who was a quant at the time and works around the quant space still. So it's got very good business day rule handling and time zone handling for international dates, but I don't know about specific holiday days. All right. And so there's some couple more examples of time deltas this time. So we can make dates, so dates on specific days or hours, but we may want delta ranges as well. So here I'm going to start with 1 day, and I want to end at 5 days, and I want 5 periods, so that'd be 5 one-day periods, and it creates these time deltas. So I could start with a date and then say apply the deltas to it and calculate the dates that come out of it. So I start with a specific date and I've got a lump of data and I want this stuff to be expressed monthly. Then it will start creating those monthly items for me. And I've got days, I've got 1 day in 24-hour periods, hourly, and of course we get hours out the other side. It's very flexible. So just to check, at this stage, those of you that are following along, does anyone have any problems running the notebook on your machine? Or are you happy that you got it running? Hands up if there's any problems. We're all good? Brilliant. So we're going to load in some open utilities data for green energy production from Germany. It's about 10 years worth of data up until 2018, I think. We'll see that graphed out shortly. The link for the data is up at the top of the notebook if you want to go and explore it, and there's much more data available, lots of data, in fact, from a big European project aggregating it together. This is a slice brought together by somebody else that we've taken here. So I'm guessing everyone's seen read CSV before, just one of the standard methods for loading in CSV data, so comma-separated value data, and it's a pretty small file. So we've got 4,300 rows and 5 columns worth of data. We can take the head of that, and then we get a date, which in this case has been correctly interpreted as a date object. Sometimes you load in dates and they're represented as strings. Pandas doesn't recognize that. It prints out during head as what appears to be a date, but actually it's just the string. And you start to do time series manipulation, and then you find out that, oh no, I've just got a string like any other string, a list of names. And then you have to do a little bit of conversion. It's very easy to do the conversion, but it's always good to check, and we'll check that in just a moment. You can see that we've got our consumption, so this is people using power, and then the generation of wind, solar, and the combination of wind and solar. And at the beginning of the data set, those data items are missing. They're nan, not a numbers. And at the end of the data set, they're all filled in. So we go from 2006 to 2017. Early in the data set, we're either not recording or not generating those green power sources. I guess not recording. And then by the end, it's all being recorded. So we can look at the D types. We've got an object for the date, and then the rest are represented as float 64 numbers. Nice and easy. So then we can use set index. So here we've used set index takes an arbitrary column and assigns it to the index so that we can start getting data from getting subsets of data by specifying not row numbers, not the 100th or the 200th row, but a date range. And we can specify that date range by just typing out a date range, and Pandas will figure out what indexing we're after. So here we've set the beginning of the data set, 2006-0101, with our consumption data. And if we call up that index item, we see that we've got it's a series represented as an index object. It has a name right at the bottom called date, so date with a big D. So that name is a property. You can ask the index for its name, and it will tell you which column it came from, the date column, 4,000 items in it. And there's a shortcut method for generating the same thing, but we've done this, we don't really care. So let's have a look at this one. So now we want to make up some new columns. Has anyone not made up columns of data by manipulating existing columns before? Nobody? Some of you? A couple of you? So in Pandas, you can make new columns in your data frame by manipulating existing columns. I mean, that's the reason we've got Pandas. It makes it really easy to generate new columns, not just add columns from external sources and add them into a data frame, but take something that's there and transform it, maybe combine it with other columns to generate new columns. When there are certain column types that let us do extra transformations. So with a string column, a column containing textual data, you can do things like call the standard Python string function. So you can say for this column, drop into the string mode and pull up the length of the column, the length of the items in this column. Or for every item, see which ones start with the character A, or do a find operation. So you can do all the string manipulation. With datetime columns, we can run through all of the data. So here I'm going to say that first row, I'm going to make a new column called year, where I take the index and I extract from that datetime object just the year. So I don't want the whole datetime, I just want the year. So it pulls out the year from that composite datetime object. Then we do the same for the month. We can ask for the weekday names. This is a newer Pandas feature. There was an old synonymous function, synonymous attribute, not a function. It didn't have round brackets on the end. That's been deprecated, and day name replaces it. So if you've ever got out the, I forget what the other one was called, the name, so that's the string representation of a day in a datetime object before, you'll find that's been updated in Pandas recently. So we can call index.dayname, and we get the name out, Monday, Tuesday, Wednesday. We can pull out the weekday just as a number, so a numeric indicator, 0 through 6. Is weekend? I can say, is the weekday in the set of 5, 6. 0 is Monday, 5, 6, Saturday and Sunday. And that gives me a binary indicator. So I can generate some new features. For those of you doing machine learning, you know that generating new features is absolutely critical for any of our work. Anyone telling a visual story, you probably want to make a nice visual story by adding new features and then slicing your data to demonstrate points of interest. So things like the isin, the set operator, really, really nice shortcuts. So what do we have now? So we've gone from a couple of columns to this richer data set. We can see the weekday name and the weekday next to it. So they're tied one-to-one. All 6s are Sundays, all Mondays are 0s. Sunday is a weekend, Monday is not a weekend. And 2006, first month, matching up to the date index. And we've had a look at those already. Fine. So, those of you that have done data analysis for any amount of time will know, and I have a very, very strong and heartfelt position on this, your data lies to you, and it generally tries to trip you up, and perhaps it's trying to get you fired. It's been trying to get me fired for a decade and a half, and I resist those attempts. I resist those attempts by printing out lots of things. We get to graphing to make sure it all makes sense, but I count things at the beginning just to make sure that things feel sane. So the value counts function is brilliant. If I had a really weird distribution of data in my time series set, I would not expect value counts to give me an equal number of Mondays through Sundays. But here we get an equal number. There's one extra Sunday, so the data set has one additional working day in it than might otherwise be expected. But it's not the case that we have a surfeit of Mondays through Fridays and hardly any Saturdays or Sundays. That would indicate that we'd lost data logging on weekends, perhaps, suggesting a systemic error somewhere in the data collection stage, which I really want to know about if I'm going to start to do some analysis. Here we've got a really nice, clean, consistent data set. And describe is a very standard way of looking at the numerical characteristics of our data set. One of the flaws of describe, not a flaw, it's just that it can't be done, is that we can't calculate these statistics for string columns. So some of our data set now is string columns, we can't do anything with that. But for the numeric columns we can. So for consumption, we can see that we've got 4,383 items. Brilliant. For wind, so that's the count, the first row. For wind, 2,920. That's because about a third to a half are missing data. So that's our first indication that we're missing a bunch of data separate to the other indication that we had earlier on. So maybe this tells us we need to go and look into our data and backfill if we want to do some more analysis. At least we've got a flag that something's a bit up. The minimum and maximums are good things. They're sensible things to go and check as well. Consumption that is positive, that's pretty good. We don't get a negative consumption. That might suggest something really weird has gone on in our logging. The fact that the ranges say the minimum for wind and solar is 5 and 1.9 as opposed to a consumption of 800. That's kind of different. That's different by orders of magnitude. That might mean that something is up. It might mean that our units are unspecified and we need to go and specify them. Or it might just mean that early in the days of logging this power generation, not much was generated, and so these numbers are sensibly low. But at least we get a clue to go and look into this. And for year, we can see with the describe, we've got minimum 2006, maximum 2017, so we've got the same data set, and our months range between 1 and 12. So again, just a sense check that things look pretty sensible. So we can do indexing. And indexing is incredibly important, of course, into our regular data. When you get to date-time data, it becomes a bit non-obvious how you do your indexing. But you can just use the lock function. Hands up if you use lock normally. Ooh. For those who don't use lock, what else might you be using to index into your data? I'm curious. iLock, okay, yep. So lock and iLock, we'll come to iLock in a second. There's the at operator. Anyone using the IX operator? That's the one that's deprecated, absolutely. IX is bad. IX does everything, And that's great if the things you're indexing into have a unique way of indexing into them. If you've got a numeric column and you use IX, it might do positional-based indexing with the number, or it might look for the thing that is named by that. If your indices starts 10 to 100, 10 might mean the thing that's 10th in, or 10 the index, which is the first item in the index. IX does all of those things, does different things depending on what it's given. That was the old way of indexing. That can get you fired, because you can make really bad mistakes with that. So you should never use it. It's been deprecated, and it warns you that it's been deprecated. And so we use lock and ilock. Ilock is the integer location. Go to this ith location just by counting through, and lock says, look this thing up based on the label I've given it. So here I can say, I want the item at 2017-0810, and then bang, we get our series item out. That's that row of data. Another caveat. In Python, our indexing is always from this thing, so from, say, the 0th thing up to 10 will be 0 through 9 inclusive. Datetime indexing in Pandas is inclusive of both boundaries, not inclusive and exclusive like in the rest of Python. I don't understand this. It has caught me out in the past. It will catch you out. Just be very aware of this. So if we do this, we will see that we get 20, 21, and 22, so 3 items, not the usual 2 that we would get. I don't know why. I wish I knew why. It's different to the rest of Python. Just be aware of it. We can also do partial matching. So I can say 2012 February, and then don't give it any days, and then I get 30-odd days worth of data back for all of February in that year. So that's really nice. I get partial matching, and that comes for free. Let's do a bit of visualizing. Who's used Seaborn before? Some of you? Okay, good. So, Seaborn builds on top of matplotlib, and it gives us some richer graphing and richer statistical summarizations, and we're going to cover a bunch of those in this tutorial. So first of all, we can take this consumption data and plot it. Here we've set a line width 0.5 to make the lines quite thin, because there's a lot of data. You can see that by default, matplotlib, which is underneath Seaborn, has picked a sensible datetime formatter. There's lots of data, over a decade's worth of datetimes, so it's picked the year formatter, and so we get on the x-axis 2006, 2008, 2010 going across. We get our consumption between roughly 1,000 and 1,600, and then we see some patterns. So it tells, this one's obvious, but someone shout out, what's the pattern that's going on here?
Winter is higher.
So winter, the cold months, we use more energy. The Germans use more energy, but we all use more energy in the cold months. I don't know how the energy is consumed specifically. There are other data sets where they break down all sorts of interesting usage characteristics. This is just consumption of energy, of electrical energy. But yeah, in winter we use more, and in summer we use less. And we see this nice cyclical pattern every year. Do we use the same amount every year over that 10-year range? Don't be so quiet. No, we don't. It goes up and down a bit. We don't know why that is. I do have a question for you later about some of this, which we'll look at. So what if we look at these? I'm just going to zoom out, and then I'll zoom back in for the other gentleman. Here we've got a bit of code that generates 3 plots for the 3 major factors that we have here. One for consumption, and then we've got solar generation, which starts later, many nans there, because earlier it either wasn't generated or wasn't logged. And then wind, which also is, we have more of it than solar, but less than for the consumption. Can you tell me something you see in this data set? There's a couple of things we can see here. Give me some feedback. And don't be shy. Absolutely, right, yeah. So for solar, we see a nice clear peak, and then it drops off in winter. And when it drops off in winter, the amount of power being generated by solar, the range seems to be quite small, but in the summertime, the range is quite big and quite pronounced. So that's kind of interesting. And solar, also, we see an inclining generation of solar over the years. What do we see with wind?
There's also a massive increase, but there's also an increase in variance from early to later.
Right, so we see a similar increase in the trend, but yes, that change in variance is really kind of interesting. So we see those peaks, they're there, but in the winter, the minimas aren't so small. So in the winter, great, we get lots of wind. Or actually, That's the other thing I think here. The cycles have a counterpoint to the solar generation. It's clearer when we look at this later. In the winter, it's windier. We get more wind in the winter. And in the summer, it's less windy because the weather's nicer. So actually, it's, the two cycles are out of sync with each other. And the variance is much higher, so it's harder to see that signal. We'll clear some of that up in a bit. What do we see with the consumption? Each data point is a day.
So you see weekdays and weekends?
Yeah, right. Well, we see two patterns, and we can hypothesize, and we will test that they are weekdays and weekends. But yes, we see two patterns, absolutely.
And there is also the wind and sun, the scales are different, so the wind looks smaller, but it's still...
Right, yeah, and we haven't normalized the axes here, so consumption is up to 1600, solar up to about 200, and wind up to 800. And so really, solar looks really clean and kind of cool, but actually it's really tiny relative to everything else. We'll normalize it a bit later on as well. Good spot. So what pattern do we see here? So what are we doing first of all? We're doing something interesting with the lock operator. So we're asking lock to find everything in 2017, so it's 365 days worth of data in 2017, and also just the consumption column, so just one column rather than all the columns, and then we're plotting it. And so we can see some interesting wibbly-wobbly patterns, and I would like you to interpret these patterns for me. And there's a couple of patterns in here. So what do you see? Oh, there's the obvious one that consumption in summer is lower than consumption in winter, sure. Looks like a weekly pattern, absolutely. Looks like a 7-day window we see there. It's not a super clean weekly pattern. If it is, there's certainly some interesting bits in there. I'm not entirely sure what they are. I've got a hypothesis, but I'm not entirely sure.
There was a massive crash at the end of the year.
Massive crash at the end of the year. Everyone just turns all the lights off and goes home. There's a massive crash around Christmas time. So presumably that's workplaces shutting down and then people having holidays. And so we're looking perhaps at personal consumption rather than industrial consumption at that period. I don't know if that's true. I haven't dug further into the data to see that. But we would look at this and think, hey, there's something interesting going on in here, right? There are some odd patterns in here. It's not a clean cyclical annual shape. There's more to it. There's some other layers going on that we'd need to pull out.
You can see day-offs as well.
Who's saying that? I can't see you, sorry. Oh, sorry. Say again?
You can see bank holidays.
Ah, right, and so that's what I think we see with that, and I've got a question for this coming up. Yeah, and I'm assuming they're bank holidays or something like that. But I don't know the German calendar. I did check some of it, but I don't know all of it. So here's your first mini exercise. So just above, you've got the guts of the code that you need for this. So if you've run it to here, and if you haven't run it to here, just do run all cells above, and it will run you to this point. I'd like, for 2017, not just consumption that we had before, but consumption and month, to pull out a subset of that data. So not draw it straight away, but just pull out, for 2017, the consumption and month figures. And then group by, and I'm presuming you've all done group bys before, you just use the group by function, and I'll work it with you in a moment. Use the group by function on month, and then that will give us, and then, what do I say there? Then I want the mean. So take the mean of that group. So we want the 2017 grouped by month mean consumption, so the average consumption by the month. And then if you're very keen, you can either try some of the other functions from group by, so not just mean, but sum, median, standard deviation, variance, and we can try to draw it as well. So I'll give you 2 minutes just to put that together and try some of those variants. So I'll start to solve this up on screen. So first of all, I'm going to extend the use of lock to take the 2017 data, and rather than just getting consumption as a single pair of quotes, I've put it in a list, consumption and month. So I want the pair of columns, I want a data frame back, not a series. And then once I've got a data frame, I can apply group by to it. A group by on a series would make no sense. There's nothing to group. There's no additional columns. But with a data frame of at least 2 columns, I can do a group by. So now I can do group by. And when I do a group by itself, oh, what did I get wrong there? Oh, group by on a thing. I have to tell it what to group on. So group on my month column. Then I get this really inscrutable object. Group bys are a complete pain in the backside as far as I'm concerned because they're really hard to diagnose. Particularly if you're grouping by on several different things and you're trying to do more complicated things, you just get this object that you can't do anything with. It's a right pain. But if you're just grouping on a single thing and you've got one other column and you know that it's all numbers, the basics should just work. So here I can do a mean, and then I should get back for my 12 months, my 12 means. Is anyone having any trouble with that? The rest of the exercise or the rest of the material is not dependent upon this, so we can skip over it. But if you're doing it and you want to do it, I'd rather you've got it. Is that working for everyone? No? And a bunch of you have done group bys before and you know this, you're not surprised by it. Those of you doing it for the first time, might take a moment to work it through. It's worth noting that with that group by, I could have got a number of columns, so I could have had consumption along with months, along with wind, along with solar, and then grouped by month, and then done the mean, and then consumption, solar, and wind would have all been mean. So I would have had 3 columns of results rather than just the current one.
If you omit 2017, you just take the entire...
You get the all 10 years worth of data, yeah. Which will be fine. We just smudge the months over 2017, 2016, 2015, all of the Januaries merged together. And that's fine. We'll probably get a more robust result for consumption, because we saw earlier it looked like a fairly stable distribution. The population of Germany is not changing significantly in this time window, so the energy usage hasn't changed drastically. Now, we get this series back. Brilliant. It's indexed 1 to 12. Great. We can see that it's indexed by months, but it's a bit hard to see. We'd like to visualize this. So what can we do to visualize it? What's the easiest thing we can do? Plot. Right. So if I just put plot on the end, then I should get that back. And so now from months 1 through 12, so January through December, I get my mean consumption, and we see, accepting that the y-axis range hasn't been normalized from 0 up to a large number, but we still see the trend in the data. Summer months, lower usage on average, and then winter months, higher usage on average, except for that kind of strange quirk in December where less is used. I presume that's holiday related, but I don't know. Did anyone have any difficulty with that? Any questions that we should address? Does anyone have any questions in general at this stage about date-time manipulation and summary statistics with group bys? No? All good? Okie doke. So let's dig in a bit and look at some daily behavior. So here I've used lock, taking out January and February inclusive, that slightly odd, non-standard inclusive range behavior in pandas with dates. In regular Python, you expect to get January back with this, but not February. In pandas, we get January and February. And we're calling out the consumption column just by itself. And then inside the plot function, we're saying we use circles for the markers, so they become more visible points. Otherwise, we just get lines with no apparent breaks in them, apart from the angular change that you would see. The circles make those days really obvious. The circles also serve a different purpose from my own usage. When you have missing data, has anyone come across that before? And why might the circles be useful in that case? Well, right, so it might be that we see what appear to be really 2 weeks worth of continuous incline. Brilliant. And then when you plot those dots on it, you realize you've got 2 weeks with a dot at one end and a dot at the other and nothing in between. And actually this perfect trend that you've noticed is just a drawing aberration, saying there was a low value and a high value and no data in between. So we draw the dots, and then when we've got missing data, thankfully we don't have any here in this bit of the data set. When we've got missing data, we can see all those data points being rendered, and we know we can trust the data that we're looking at. So when I look at this, I think, oh, there's kind of a 7-day pattern going on here. Oh yeah, I'm pretty sure I trust that 7-day pattern because it looks pretty consistent and I've got all of my data points. So here we're changing the formatting slightly, adding a slightly nicer title, but it's the same chunk of data. Anyone used the mdate date formatter before? Yeah? How much success did you have with it? Yeah, I'm still terrified of it, because it kind of works, apart from when it automatically decides to do something else, and then a fun hour's worth of debugging ensues. It's getting much better as Matplotlib matures. I mean, okay, it's already 15 odd years old, but as it matures into our different use cases, particularly into its Pandas integration, it's getting better at rendering date-time information, but it can still get a bit messy and a bit weird at times. That date-time formatter, it was an addition to the library to make it easier to dip inside the internals and change the rendering options without having to write your own functions. So you're just telling it the B and the D. I'm guessing that's a month and a day signifier. I don't know why it's % lowercase b. Maybe that's a 3-letter code for the months. And there's various string formatting options you can put in there to specify how you want those dates to come out. So it's kind of flexible. So let's group on weekday and see if things look a little bit different. So I can group on weekday, and then I visualize it, and then we get our really obvious change at the weekend. It's kind of nice, just reusing the previous couple of lines of code and changing the column that we're indexing off of or using for the group by. But it's not super nice to look at that weekday 0 through 6, so we can make a little change we've got in the cell below to map those numbers 0 through 6 to strings, which we can then use to label the graph. Who's used the map function before on a dictionary, just to remap things? Just a couple of you? Okay, it's kind of a powerful feature. So you ask, normally I'd use an apply function and then apply with a lambda to take a column and then apply the lambda to do something like look up a value in a dictionary. Map's really nice because it just takes a dictionary and it maps items into your dictionary by key, pulls out the value and replaces it. So we can run the same thing and then we plot that. And then we get a more interpretable result. And if we're telling a story to colleagues, we really want an interpretable result where they can look at it and they haven't got to say, Ian, decode for me, what does that 6 mean again? Think, oh yeah, it's the 6th day in 0 index, so actually it's a Sunday, which you might think of the 7th day. We don't want that, we just want nice labels. So Matplotlib makes it easy enough, along with some pandas, to label everything. Anyone who's used it for enough years knows that it's easy enough, but it's not perfectly easy, and it goes a bit weird at times. But you can always solve it. Sometimes the path there is a little bit wiggly. But the pandas integration is pretty good and always getting better. Right, so let's look at some seasonality. So and I'm going to zoom out again. So here we're using Seaborn. Remind me, who's used Seaborn before? Okay, so a handful of you. So the rest of you should be using Seaborn. Seaborn's really nice, not for time series functionality. It's got some of that in there. I use it mostly on my non-time series data. It's a bunch of high-level statistical plotting functions that build on matplotlib. So whereas Pandas, when I plot, I can ask for a box plot and I get a basic box plot. With Seaborn, I can give it some different categories and say, make me a number of box plots based on these categories, and then draw some extra whiskers and other bits on there. And it just handles it for me, and it does it really nicely. So I super recommend Seaborn. We're going to use a couple of Seaborn charts next. So what can we see in this? Tell me a story about what you see on screen here. So this is using all of the data, 10 years worth of data, not just the single year we were looking at before. Summarization is a bit different. We've got a box plot, so we can infer some things based on the characteristics of that box plot. I'm really curious. What do you see here? I don't want to tell you the story. I want you to tell me the story. What have we got? Maybe a precursor question would just be, who is comfortable with box plots and their interpretation? Put up your hand if you are. Right, all of you with your hands up, start speaking. What do we see here? Right, so that's one interesting thing. So on the wind chart, we've got what looks like a standard box plot. We get the whiskers, and then we get some black crosses. The black crosses are outliers, in this case defined by being more than 1.5 times the interquartile range away from the median. So the interquartile range on the 12th column, December, that's the right-hand purple box. The interquartile range is the outside of the main box, and then more than 1.5 times that on either side. Anything outside of that would be an outlier. Okay, so the median is higher, but then the 25th percentile is lower, further away from the median than the 75th percentile. Yeah? So yeah, at the weekends in each of those months, we have much less usage, disproportionately less usage than we do for the other 5 days of the week. Yeah? So we see a box plot where the median is not in the center, but is offset, telling us about skewness in the data. What else do we see? What can you tell me about the reliability of solar versus wind? What has lots of outliers? So yeah, wind has lots of outliers, but solar doesn't. So that's kind of interesting. So if I want predictable power generation, solar's looking pretty sensible. We know the range is smaller than it is for wind, but it's more predictable. So I've got a better input onto the grid for power generation with solar than I do with wind, but wind gives me much more. So I've got more variability in the generation, and I have to do storage at that point. And I suspect, Jens, this is your area, isn't it? Really, you should be lecturing this bit. If you want to know about the dynamics of generation of power in Germany, Jens is over from Germany, and works alongside these kind of data sets, talk to Jens. He knows all about this stuff. He can tell you about the storage and the monitoring and the big data problems around that. I think also on the solar side, it's kind of interesting thinking about the outliers on the extreme months. So in December, typically, we get a small amount of sunlight, so a small amount of solar potential. We don't ever have any really dark days, so we don't have negative outliers. It's not the case that we have blackouts, but we do seem to have some very sunny days in December and January, so we have a couple of positive outliers, whereas it's much more evenly spread during the summer months, as you kind of expect. And then for the wind as well, yes, we don't have negative outliers, but we do have days when there's little wind at all, or maybe no wind, but there's never negative wind. Of course there isn't. But then there can be some really, really crazy, powerful windy days, I guess big stormy events. What am I doing here? So I'm using a box plot just on the weekdays and looking at consumption. And so if we look at the consumption spread over the days of the week, We see pretty consistent patterns on Sunday and Saturday. And for most of Monday through Friday, we've got a very consistent distribution, except for those negatives, outliers. And as we suggested before, perhaps those are holidays. It's kind of weird, but we don't really know. But it's not the case that on some Mondays through Fridays, we have positive outliers, where there's a crazy high usage of power. So I guess we don't have huge, great industrial festival days where everything gets turned on, but every now and again everything gets turned off. So we see this skewness in the data. Ooh. Not a silly question at all. It's a very important question. Thank you for bringing that up. I didn't add in an extra parameter that would have made that go away, and so it's a brilliant question. So the sort order that Seaborn uses is based on the discovery order. So the first time it found a consumption item would have been on a Sunday in the data set. So it started counting from Sunday, then Monday, blah, blah, blah. There is a parameter. Anyone know the parameter in Seaborn offhand that lets you supply? It's not called sort. It's called order, I think. I think it's hue order and order. And then you give it the string of Monday through Sunday, and then it will display in that order instead. Important question, because all these graphs always come out in the wrong sequence that you want. This one at least came out in a weekly sequence that was useful. It wasn't completely jumbled up, but I think some of the ones further below do, and then we have to do that sort. In fact, next couple of cells, it turns out I wasn't happy with that sort order. So I supply the order parameter. Forgot that was coming up. So I supply the order parameter using that dictionary that we've used before, where I made the dictionary in order 0 through 6, Monday through Sunday. So I take the values out of that dictionary, so I just get a list Monday through Sunday, pass it into the order parameter, and then my box plot comes out Monday through Sunday instead. That's an important distinction for dictionaries in Python. It's a recent version of Python. I think it was 3.6 or 3.7 that we have now. Dictionaries preserve their insertion order. It used to be the case that typically you've got the order things are inserted into a dictionary, you would extract them in the same order if you got the values out, but it wasn't guaranteed by the algorithm. In recent versions of Python, it is guaranteed, so you can use it as a sequence in order. So you can use it for things like labeling if you construct the dictionary in the right order in the first place, which is kind of handy. So let me get to that holiday question. And I was curious this morning, and so I added this cell in just to see if I could figure some of this out myself. I'll make this a bit bigger again. So here I'm saying, for the daily data, for the weekday name of Monday, generate a mask. Take my data, use square brackets, so this is indexing with a mask, and pull out just the Mondays, so I'm pulling out every 7th day, and then run a query. Why have I not included that weekday name question inside the query? Which is the question maybe you were going to ask. It's a really banal reason why. Because it would have been easier to write opsd daily.query, quotes, weekday name equals Monday, and consumption less than 1,000. And indeed, that's what I first wrote. Because of the space. It's really banal. We can't have spaces in our column names inside a query. And I followed the bug tracker on this this morning. I read through on Pandas. There's been lots of discussion around it. The short answer is we're not allowed spaces. And it's a bit more nuanced than that. The query engine is rendering Python out of that query string. And so when it sees spaces, it sees non-standard syntax that makes no sense, and it will blow up. The reason that we aren't doing clever interpretation on that query string is that rather than having spaces, you could have dots or slashes or colons or semicolons, which would have interpretation inside Python as well. Those things are all valid inside your column names. And so we'd have to write a really sophisticated interpreter just to get the query feature to work. And then when I read further into the bug tracker, it said, and actually the query feature was put up as a nicety, where really the recommendation is we use masks. Now, it turns out in practice, writing queries is kind of natural, and writing a mask is a little bit of a pain because you have to think about it a bit more to make your binary mask. So I think a lot of people have adopted queries, but then you end up with this issue that you have spaces in your names or dots or colons, and then your query fails with a really messy error message. So I made a mask, so daily mask lets me get 1/7 of my data, just the Monday's worth of data, and given the Monday's worth of data, I run the query, asking for anything where the consumption is less than 1,000. So that will get me, for this Monday, all these points here. There's 11 of them, and then I sort them by month, just so they line up and we can have a look at them. And so for the Mondays over all of my years, we can see a couple of Mondays here, so 24th and 31st. So Christmas Eve is a public holiday in Germany, is that right? And New Year's Eve as is New Year's Day. Okay, so yeah, New Year's Day in the UK, not New Year's Eve in the UK. Is that right? Am I getting that right around?
Both of which are.
No, New Year's Eve is not a public holiday.
December is public holiday as well as 1st of January.
Oh, say that again, Jens?
1st of January is public holiday,
Yep.
and 31st of December as well.
But in the UK, that's not the case, is it?
It's not in the UK.
Yeah, okay, right. Checking. Good. So to support the hypothesis, still a hypothesis, that those negative low outliers that we saw might be because of holidays, seems reasonable. We can investigate the data more this way and dig a bit into it if we want it. Who's used autocorrelation and lags before to look at patterns in their data? 1, 2 of you? Okay, you'll see something new, good. So one of the things with time series is we hope that, well, depending on the data set we're looking at, we may or may not have patterns. If you're a quant working in finance, you desperately want to see those patterns, and there's a million other people around the planet looking at the same data sets, looking for those patterns too, and so finding easy to spot patterns is really hard. But in other data sets, if we look at the CO2 data set over the last 100 years for the planet, it's really easy. It just goes up and up and up, and there's a really obvious pattern, and we can see which way this is going, and we know that CO2 production and storage in the atmosphere is a big problem for the planet. It's a really, really clear pattern, and we have to do something about that. That's a wider, separate discussion. For energy generation, we see a similar cyclic pattern on an annual basis. We saw the energy usage being higher in the winter and lower in the summer. And the same with our power generation. So some different patterns there, but they're cyclical. So we should be able to detect some kind of signal coming out of this. Pandas has a couple of really useful functions for this. Autocorrelation is one of them. This plot is too busy, so we're going to break it down in the next couple of plots. Here we're saying over our 10 years worth of data, for every data point, look at how similar it is to the point next to it. And also how similar that point is to the point 2 points away. And how similar it is to point 3 points away, 7 days away, 30 days away, 365 days away. All of these things. The fact that you see any pattern here at all tells us there's something in here, but that's all smudged up and horrible. We can't really dig into that. So we can look at just, say, the first 30 components. And then we see something kind of interesting. Here's our weekly pattern. So we get an autocorrelation, a correlation, just looking at the point today and the point in 7 days' time. So my Monday and the next Monday. And we see at the 14 point, so that's 2 Mondays away, it's pretty similarly related to my current Monday. This is throughout all of the year, my Monday and 2 Mondays away, pretty similarly correlated. My Monday and the next Monday more so. My Monday and 4 Mondays away, a bit less so, but still pretty strongly. And the same for Sunday to Sunday and Tuesday to Tuesday. But Monday to Thursday, or Thursday to Sunday, sort of the 3 or 4 gap, kind of zero correlation, very little going on in there at all. So we don't tend to see a pattern just a few days away. So if you do this on your sales data or your website visit data, these kind of patterns come out super clearly. I was analysing baby breathing data with the NHS a couple of years ago, and you can pull out the frequency of a baby's breath when they're on an incubator, so when they've got artificial respiration going on. You can see really nice patterns coming out really clearly, enabling really easy signal detection, so you can then intervene and do things. If we look at the same data over 360 days, so we've got a year's worth, we can see that up to about 160 days, so that's half a year away, my correlation, even on a Monday to Monday basis, there's still something there, but it varies quite widely and it's getting closer towards 0. But my annual correlation, so Monday to Monday, looking at December to next December, actually pretty good, pretty strong. So it turns out our consumption data annually over 10 years is pretty strongly correlated, just all over our winter to winter, Monday to Monday, and whatever time frames. So we get a really strong, really consistent pattern coming out, incredibly consistent pattern. I mean, this is kind of crazily consistent. And a lag plot, let's just do something a little bit similar. So with a lag plot, it's basically a scatter chart looking at my point today and the point tomorrow for all pairs of today and tomorrow. And so today is yt on the bottom axis, tomorrow is yt plus 1 on the y-axis. So if my data point today looks like my data point tomorrow, and the data point after it looks like the one after it, we'll see some kind of structure in this scatter chart, some kind of lines or wavy circles or something. With breathing, if you're capturing the flow of air, you end up with kind of a circular pattern. If you get a sine wave, you get a circular pattern. Looking at this data set, we get kind of these streaky lines inside it. We don't know what they mean right now. We'll dig into that in just a second. But we see some kind of pattern. If you had no relationship between the data on day 1 and the data on day 2, you'd have a random noisy field of just random dots all over the place. And that's a really easy visual inspection that lets you look at your data and say, oh, there's no relationship in here. This is rubbish. So-and-so told me I'd find a really good, clear relationship in the data. There's nothing here. Maybe my data's wrong. Or, heck, I've got some pattern in here and I can exploit this. What can I do with it? So we might ask ourselves, what's going on in this data set? Is it the case that these clusters represent different things? And we're building up to our next exercise. So here I've said, well, let's take the consumption data, and let's take for the C, so that's coloring in matplotlib, that C argument is passed through lagplot into the underlying matplotlib function, and it applies C for coloring. And I'm asking it, well, take isWeekend. And because we've got 10 years worth of data and the lag plot looks at a point to the next point, we've actually got 10 years minus 1 day's worth of data. So I can't use 10 years worth of isWeekend. I have to use 10 years minus 1 day, which is why the minus 1 for the isWeekend (-1) up to everything but the last point. And so I've said color the point by isWeekend. So if isWeekend is true, give it a color, that'll be yellow. And if isWeekend is false, give it another color, that'll be purple. So we see 2 streaks. We see a Saturday and a Sunday. Of course we do. And it means that the other streaks, those are kind of those 2 patterns, those 2 oscillations we saw on the consumption chart. We don't quite know what it is at the moment. We can take a pretty strong guess, but don't know what it is at the moment, and you're going to check that for us. So we can look at this and think, great, we've got some structure, we've got some daily structure coming through in the lags. The time series reflects days and weekends. We could exploit this. We could do something with this in a modeling context. So we remember that we had weekdays and week names. That's just to remind you which columns we had there. And then here's your exercise. Can we do the same thing that you had before? So the same thing that we had up here, but not colouring by isWeekend, but colouring by weekday. That's the easy one. So the question is, do we see daily structure in the data during the working week? Is it the case that that bunch of purple points we had before are just all smudged together? Or are they actually streaked by colours by those days? Do we see some finer structure in there? So you can probably guess what the answer is. Can someone interpret? What do we see? We're colouring, and I'll give you the clue as to what the colours mean, using the Viridis colour map. That scales from purple for zeros, so our false that we had before, and now it's the index of a Monday is 0. If I said down thumbs, that's bad, just low number. Up to a 6 will be coloured for yellow, so that's the highest value in this case. So 0 through 6, purple through yellow. So what do we see? I mean, do we see daily structure during the working week? Is it all smudged together, or do we see streaks of colour that seem to be self-similar? Yes or no? Someone take a punt? Streaks of colour? Any other votes for streaks of colour? Okay. Separate question. Can anyone tell me why we like the Viridis colour map? It's... Yes? Do you know what that means? So it does something interesting to our perception of the colour map. Was there an answer over there? Right, so with the old default jet colour scheme, the one that we're super familiar with and was inherited out of MATLAB, that one was not, it didn't have a linear mapping of, I think it's intensity, over the values being displayed. So some parts of your colour range appear to change rapidly from reds to blues, very quick colour changes, even though the underlying linear numbers we were looking at didn't change rapidly, and other parts of the colour space appeared to change very slowly, even though the linear numbers are changing at the same rate. The Viridis colour scheme is perceptually uniform, so we should all, and it's important to note, we should all, even with our colour deficiencies, perceive a more or less similar thing, much better so than we would with the old jet colour scheme. Doesn't work for people who are properly colourblind or have interesting colour blindnesses. I have a minor colour blindness. I forget the name of it. I have a red-green, I think, minor inability to distinguish colours. So if you give me 7, not a triptych, but a 7-tich of 7 colour pieces, about 3 of them look very similar to me. And it would mean that if I look at this kind of thing, I think I can see the same thing that you can all see, but we don't know. And 1 in 7 men and 1 in 9 women perceive the world a bit differently according to this colour deficiency in our vision, and it's a thing wired into the eyes. We can't do anything about it. And then other groups of people have other colour deficiencies, and some people only see monochromatically, so only see in black and white. So Viridis makes it easier for most people to see what's being expressed better, and that's why it's the default inside Matplotlib now. And also it renders better in black and white. So when you print things out, there's a better chance that you can see differences that are expressed in the grayscale. Okay, let's move on with the tutorial. Date range, we'll get to some resampling now. We're going to change the frequency of our data and look at some rolling means. So we can make date ranges, something I mentioned back at the beginning. So here I've asked for a date range, 2004, September 20th, 8 periods, hourly. So we start with 1 day, and then we work through 8 hours on that 1 day. And you'll note that that datetime index that's been output, there's a frequency that's specified, H, hourly frequency. So we can see how it was generated. If we look at our data that we've read in, we'll see that there's clearly some kind of frequency inside our data, but the frequency is set to none. That's because we read this data in, it wasn't generated by Pandas. We don't know what its actual spacing is. So we might enforce upon it a particular spacing. And so what happens if we want to start resampling our data and changing the frequency of things? We'll start with a simple example. I'll take 3 days, so a date time, 3 days in 2013, and I'll use those as indices to index into our energy data and pull out the consumption column. So we get 2013, 02, 0203, and 0206, and 0208. So 3 days will be some gaps in between. And if I ask it to resample, or sample with a different frequency, so not just with the intrinsic data that we had, but to sample at a specific frequency, I want daily frequency, it makes up the days that we were missing in between. Brilliant! only we haven't got data, so we get nans. Not so brilliant. So filling in those nans then becomes the next question. What do we want to do? The better answer is always to go and find the true data and fill in what's missing. Often we can't do that. So one of the ways to do it is to fill in based on the data that you've got available. And here, for example, we can do a forward fill. And so when we do an as frequency to change the frequency of our data, we can say the method is forward fill or backward fill, or there's other things we can do.
Would it be good to fill with the average, right?
Well, we could do different things. In this case, well, it depends on what we want to get out of it. So when we're filling things in, the same as when we're filling in missing data anywhere, we're lying in some way, and we have to make sure we're lying in a sensible way. So here I'm saying those days in between, we're going to forget that we didn't know what they were, and we're going to say that they're the same as the day behind us when we last had a good value. Or we could interpolate, or we could say, I want the future value dragged back in time, but we have to know what it is that we're, why we're lying. So there's different answers always. But the nice thing is we can fill in something, so we can get something out of this. So here we're going to downsample our data. So under columns, I've got resample up here. I'm going to resample with a W, so that's weekly. So I'm going to take every 7-day period, not a rolling 7-day period, but every 7-day chunk, and I'm going to sample that with the mean down to a single value. So I'm going to get a single weekly value for each 7-day contiguous chunk of data. So it's kind of a coarse way to look at my data and summarize it down, and I'll get 1/7 of the data that I had before. And so I do that for a set of my columns, and then I get my weekly sampled data. So for visual storytelling, we know that there's a pattern in the weekly data. Maybe we've told our daily data patterns to our stakeholders, and now we want to look at the bigger pictures. So then we can start to draw some compound graphs. Here I've taken a subset of the data, 2017-01 to 06, so January through to June, and I'm taking out solar, and I'm taking the daily data, those are the blue dots, so we can see those points showing us each point that we've got, and I'm taking the weekly sample data that we generated before, and drawing that in orange, and then we see that the weekly sample data looks like the daily actual data. It follows it pretty well. And then in a moment we're going to do a rolling mean. If we've got, a little mental exercise for you, if we've got a 7-day rolling mean and we've got 7-day resampled data, will the results be the same? When we draw the graph, will it be the same? Some of you are shaking your heads. Can someone say why it wouldn't be the same?
We'll have 7 times as many data points, hopefully.
Right, so that's it. If we do a 7-day rolling average, we maintain our days in the first place. We lose maybe the first 6 days, because we lose that first chunk of data to generate the first of the rolling averages. But after that, yes, we have our daily data. And what about the integration of signal change in a rolling average versus a weekly chunk?
We'll still see some of the weekly trend, rolling average.
Yes. And I think typically we could say it would react faster. So if there's a quick change in the week, the rolling average would catch it on a daily basis, whereas the weekly average, if there was a big positive and a big negative change, and then it went back to the old values, that weekly average might just take the big positive and negative and the other values and squash it to nothing. Whereas the rolling average will go way and then down again and then back to normal, and we'd see something in the pattern. So if we generate the rolling average, or the rolling mean, I should use the correct terminology, average is inspecific, mean is specific. I want the rolling mean, so the rolling generates an intermediate data operator like the group by that we had before, and then we can do things with it. So we might say we want the rolling median, or the rolling minimum. We have the rolling mean in this case, so it's the same interface as to group by. I want 7 days, and centered is false. So when I generate a mean, I could say I want the mean of this looking forward and behind a certain number of days. And when we're doing certainly any machine learning analysis, typically we don't want to look into the future. Looking into the future is bad, because if tomorrow I'm trying to predict what's happening, I can't look 3 days into the future. Depending on the data analysis we're doing, with that breathing data with the NHS that I mentioned, I had a full data set, and we didn't care about looking into the future, we cared about the quality of care being given after the fact. And so the question was, given the data, can we come up with good models? And so we could do a moving average that integrated future and past events to smooth things out, and that was a reasonable thing to do. But typically when predicting the future, we can't use things that are happening in the future that we don't know about yet. So I'm saying centered equals false. And then to generate that rolling average, the first bunch of days that go into the rolling average, we get a NaN. So previously, 2006-01-01, we had consumption data. Now we lose it for the first bunch of days, so we can generate the 7th day moving average. And then if we combine these onto that plot again, now we get in green the 7-day rolling average overlaid over that orange. And you can see that sometimes the orange, and I'm looking at between 2017-03 and 2017-04, the orange kind of goes up in a nice gradual fashion, but the green, the 7-day rolling mean, is shooting up and shooting down and then coming back again. So it reacts faster. So it gives us a better quality of signal detection or change in underlying signal in this case. Okay, I'm going to get very close to the end now. You might be running perfectly to time. So let's do a bit of trend observation. So now I'm going to generate a 365-day rolling average. This is over our 10-year data set, 1 year rolling forwards. Combine these into a nice plot. Now we see a composition, 2006 through 2018. That 365-day moving rolling mean is the black thick line. It starts a year into the plot because we had to integrate the first year's worth of data for the 365 mean. And then after that, okay, there's some wobbling in there, but it's pretty static over the course of the year. The 7-day rolling mean reacts much faster, of course. It's 7 days, and so it's going up and down very quickly. And in the background, we see those grey points. And this leads to another observational question. What are we seeing here? There are some odd negative spikes going on. It's quite clear that some years more energy is used, other years less energy is used on an annual basis. Certainly there's some weird negative spikes or small spikes. They appear to occur late December. So that's not just the Saturday-Sunday effect, that's something happening around Christmas time. Really big relative to the rest of the usage change. And so we can start to tell a story with this, dig in with our stakeholders, go through what this data means, try to understand. Anyone have any observations about that? And I don't understand. Actually, Jens, do you have any observation about this? Consumption data for Germany for energy, Christmas times or December 31st, that rough period of time, and also different years in that decade. There's been some wide changes. Is there a story you might know about, or am I just putting you on the spot? Okay, so are the public holidays around Christmas? Yeah, okay, yeah. Okay, and what about the significance? So this appears to be downturns in energy usage some years. Maybe it's reasonable to say that some years were unusually warm, and so the winters weren't as cold, maybe. But I don't know if that's... Yeah, I don't know. Without putting in more data, it'll be hard to draw any good observations. But we could form some hypotheses to go and dig further into what the data is telling us. Okay, if we pull in the solar and the wind data, now we get to see on this normalized scale that solar, the orange line, is really, really small in its generation capacity relative to wind. And we can see that wind is increasing, at least in this data set, quite dramatically in recent years. Kind of interesting. And then your final exercise before you get to break and wind down for the evening. What is our share of green power over the years? So the share of solar and wind relative to overall consumption. You're going to have to calculate a new column to do this. Divide. You've already got solar and wind as one of the columns, and you've got consumption as a column. So you're going to have to divide them together, and that will give you a percentage, a ratio. and then we can graph it. So that's your final exercise, and then we can wrap up. But you can't escape until you've done that. Yeah. Oh, now you're asking a tricky question. So if you're using the C parameter to colorize, and the colors come out, how do we label it? Typically, for a continuous range, you can add a V-bar, and you'd have to do a Google for that. You add a bar on the right-hand, the normal way of doing it is to add a bar on the right-hand side of an image, a V-bar, which shows the color range over your minimum to your maximum values. And in Seaborn, that comes with a bunch of your plots. So I think it's called a V-bar, and if not, I'll find it with you afterwards. I think, yeah, V-bar will be the one you need. Right, let's solve this exercise. I'm going to copy in my notes. So I'm going to make a new column, which is called wind plus solar divide consumption. It's all just in quotes, so it's just a valid name. And I'm going to take the annual wind, take the annual wind plus solar column and divide it by the annual consumption column. So dividing wind and solar, divide by consumption to make a new column. And then I take that new column and I plot it. And actually I'll just plot it.
So shouldn't it be like PST daily, or what's the difference? The annual versus the daily?
Oh, it's a good question. We could. I was just using annual because that's what I had here, but yes, I could use the daily. Yeah. You're right. There's two sets we could use here. So here I'm using the annual just because I can summarize percentage of green by year, but you're right, we could have used daily completely. So here we get a line chart coming out of this, which is kind of informative. We don't see the points on here, and it's a chart that goes up and to the right, which is nice. It might be the case that we want to use bars in here, slightly clearer story perhaps, and then maybe we'd want to put some axis limits onto this. So if I take this, and then we'll just tidy this up. So that X ticks, rotation 0, that's because the label ticks by the matplotlib default get rotated so they're facing upright, and I've turned them around to they're flat again, so they're not turned at a funny angle. We've set a title. I've changed the Y limit to be a little bit greater than what it was before, just to give a bit of padding. It was up to about 0.27 before. Now we get a Y label at 0.3 on the Y axis, so we can read all the way to the top and see what we've got. And I've only used data from 2012 onwards, not going back the first couple of years when we didn't have all of our wind and solar. If I get rid of that 2012, we're going to end up with, I guess, I'm going to do that. Yes. So here I've used colon to say, all of the rows and this particular column. But for a bunch of the rows, I didn't have wind and solar data, so I get nans, so I end up with no data. So it doesn't look so pretty. So instead I put in 2012, 2012 onwards. And then we can see a nice, simple, consistent story that over the years, we're seeing an increase in share of power consumed in Germany, at least under this log data, coming from wind and solar production. Anyone have any problems with that? Any questions around that? No? So we're going to conclude in that case just in time for the break. So I'm very happy that that ran perfectly to time. Thank you for playing along with me with the exercises and the discussion points. I always prefer tutorials that are a bit more discursive. I like to know what you're thinking and how it's working. So Pandas is really good. It gives us lots of the basic functionality that we need. Seaborn gives us great statistical plotting on top of the standard matplotlib plotting, which comes for free inside Pandas anyway, but Seaborn builds upon it, and I really recommend you check that out and do some more things with Seaborn. If you want to go further with time series analysis, particularly time series projection, there are various techniques, but the Prophet library from Library, P-R-O-P-H-E-T, from Facebook, it's really good. Out of the box, it has a bunch of algorithms in there which do sensible time series projections with error bars, and it tends to just work. And so unlike messing around with Arima and Arimax and a bunch of other techniques, Prophet generally works reasonably well as a first pass, and it's very customizable afterwards. So I super recommend that if you haven't come across Prophet. There's definitely way more you could go into with time series around time zone handling. Thankfully, Pandas handles a lot of that for us. And if you want to do things like time series decomposition to really pull apart annual, monthly, weekly, daily trends, then Stats Models has a nice time series decomposition module which will take you further. Okay, I'm happy to answer questions afterwards. Thank you very much.